So sketch the graph of the image after a reflection in the y-axis. So we have to say to ourselves, what does that mean? A reflection in the y-axis, which values are changing? The x or the y? The x values are the ones that are going to be changing. So when we see this reflection in the y-axis, a reflection question can be written that way. They could have also written this same question by asking you to do, since this function is g, this question could have been written this way. Can you see that that's the same question just written in a different way? Or this same question could be, instead of writing reflection in the y-axis, they could say reflection, oh heavens, problems are spelling, that's okay. Reflection over, and if we're talking about the y-axis, I could write that as its equation, x equals 0. So you'll see on final exams that every once in a while they'll choose one of these three ways to ask you to do the same thing. So you have to be, as far as language goes, be able to interpret that. I think reflection in the y-axis is the easiest one because it's really visual and easy to see. This one's not so bad because you can see the negatives with the x. I think the hardest one is when they say reflect over the line x equals 0, because x equals 0 is the y-axis. If we did that, all that's going to happen is we're going to take the points that we have and we're going to label them here. So I've got -3, 1, -1, -2, 3, -2, and 5, 2. If we're reflecting it over the y-axis, it's our x values that are changing. Our x values are going to become negative. So now, and this is where a different colored pen is nice because it might get a little messy, I'm going to have this point right there. Maybe my first labeling wasn't too strategic. That point is going to be -5, 2, because the x value is going to become negative. 3, -2 is now going to be at -3, -2. -1, -2, if the x value is going to get flipped, is going to be at 1, -2. And the point -3, 1 is now going to be at +3, 1. So all I've done is I've changed my x coordinates to the negative of what they were before. Now if I draw it, I can just connect the dots. And does it look like a mirror image over the y-axis? Can you see it being flipped right over the y-axis? Again, color coding things. The domain of my red function, which is the one that we started with, its smallest x value was at -3, and its largest x value was at 5. Its range, its smallest y value, was at -2, and its largest y value was at +2. Now when we flip over the y-axis, it's affecting only the x values. So when we go to our domain and our range for the blue one, we might notice right away that our y's did not change. The range still goes from -2 to 2. But when we talk about our domain, now our smallest x value is -5. And our biggest x value, +3. Can you see that based on the original one, it's just been multiplied by a negative? And our biggest ones became our smallest ones, and our smallest ones became our biggest ones when that happened. Now what happens sometimes on the exam in a multiple choice question or a short answer question, they'll ask this same question But instead of giving you the graph and getting you to flip the graph and then do the domain and the range, they'll just tell you the domain, and well, they'll tell you the domain and the range, and they'll ask you what the new domain and the range is if you flipped it over. But you don't know what graph you're working with. Could be any graph. But you should still be able to say, oh, I know my x values are changing. They're getting multiplied by a negative, so I should be able to go right from here to here with that idea. But you'll see that more and more in this grade 12 course. How do we take a question and a little bit out of context and just ask a specific detail about it? All right, questions after this one are 3 and 13.